You're listening to leadai.dev, your daily updates on AI development. Today's topic is VAKRA benchmark exposes critical AI agent reasoning failures. Here's a quick overview. IBM's VAKRA benchmark analysis uncovers systematic failures in AI agent reasoning and tool usage, providing crucial insights for developers building autonomous systems. Now, let's ask our analyst about these developments. What's new? VAKRA benchmark reveals AI agent performance gaps.
IBM Research has released a comprehensive analysis of the VAKRA benchmark, exposing critical performance gaps in contemporary AI agents. The benchmark evaluates agent capabilities across reasoning, tool use, and failure recovery scenarios, revealing that even advanced language models struggle with multi-step reasoning tasks and appropriate tool selection. VAKRA verification and analysis of knowledge retrieval agents specifically tests agents on complex workflows requiring sequential decision making, error handling, and adaptive problem solving approaches. The benchmark framework introduces novel evaluation metrics that go beyond traditional accuracy measurements. VAKRA assesses agents across three core dimensions: reasoning coherence, tool selection appropriateness, and failure mode recovery. Each evaluation scenario presents agents with multi-turn conversations requiring dynamic strategy adjustments, contextual memory retention, and appropriate escalation when facing limitations. The framework includes 500 plus carefully crafted test cases spanning information retrieval, mathematical reasoning, code generation, and multimodal understanding tasks. Previous agent evaluations focused primarily on single turn interactions or narrow task completion rates. VAKRA's methodology represents a significant advancement by introducing temporal reasoning requirements, tool interdependency challenges, and explicit failure scenario testing. The benchmark reveals that current agents achieve only 34% success rates on complex multi-step tasks, compared to 78% on isolated single-step operations, highlighting critical gaps in autonomous system reliability. VAKRA benchmark includes 500 plus test cases across reasoning, tool use, and failure recovery scenarios. Multi-step task success rates drop to 34% compared to 78% for single-step operations. Framework evaluates reasoning coherence, tool selection appropriateness, and failure mode recovery. Benchmark introduces temporal reasoning requirements and tool interdependency challenges. Testing methodology includes explicit failure scenario evaluation and recovery assessment.
Thank you for that analysis. Let's move on. Who benefits from VAKRA benchmark analysis?
AI researchers and developers building autonomous agent systems gain immediate value from VAKRA's detailed failure mode analysis. Teams working on customer service bots, coding assistants, and research automation tools can identify specific weaknesses in their agent architectures. Organizations deploying agents in production environments benefit from understanding reliability thresholds and implementing appropriate fallback mechanisms. The benchmark provides actionable insights for teams with 5+ engineers working on agent based systems, particularly those handling complex multi turn interactions. Enterprise AI teams evaluating agent platforms for internal deployment find VAKRA's comparative analysis essential for vendor selection. The benchmark's focus on tool integration capabilities directly addresses concerns about connecting agents to existing enterprise systems. Organizations considering agent automation for customer support, content generation, or data analysis workflows can use VAKRA metrics to establish realistic performance expectations and identify necessary human oversight requirements. Individual developers and small teams should approach VAKRA insights cautiously, as the benchmark focuses on complex scenarios that may exceed current project requirements. Teams building simple chatbots or single purpose automation tools may find VAKRA's multi step reasoning emphasis less relevant. Organizations without dedicated AI engineering resources should prioritize simpler agent implementations before addressing VAKRA's advanced failure mode considerations. AI research teams building autonomous systems with multi-step reasoning requirements, enterprise organizations evaluating agent platforms for production deployment, developer teams working on customer service bots, and coding assistance organizations implementing agent automation for complex workflow management.
Great insight. Really helpful context. How to get started. Implementing VAKRA insights.
Begin by accessing the VAKRA benchmark dataset and evaluation framework through Hugging Face's Model Hub and associated GitHub repositories. Install the required dependencies, including transformers, datasets, and evaluation libraries. Set up a Python environment with GPU support for running agent evaluations locally. Download the benchmark's test cases and establish baseline performance metrics using your current agent implementation. Configure your agent system to handle VAKRA's multi-step evaluation scenarios by implementing proper conversation state management and tool selection logic. Integrate the benchmarks evaluation metrics into your testing pipeline, focusing on reasoning coherence scores, tool appropriateness ratings, and failure recovery success rates. Establish automated testing workflows that run VAKRA evaluations against agent updates, tracking performance changes across reasoning, tool use, and error handling dimensions. Implement specific improvements based on VAKRA findings by adding explicit reasoning verification steps, improving tool selection algorithms, and developing robust failure recovery mechanisms. Create monitoring dashboards that track VAKRA-style metrics in production deployments. Establish performance thresholds that trigger human intervention when agents encounter complex scenarios similar to VAKRA's challenging test cases. Install VAKRA framework dependencies, transformers, datasets, evaluation libraries with GPU support, download benchmark test cases, and establish baseline performance metrics for current agents, configure conversation state management, and tool selection logic for multi-step scenarios, integrate VAKRA evaluation metrics into automated testing pipelines, implement reasoning verification, tool selection improvements, and failure recovery mechanisms, create production monitoring dashboards tracking VAKRA-style performance metrics.
That's a very interesting point. Tell us about competitive context. VAKRA versus existing agent benchmarks.
VAKRA distinguishes itself from existing benchmarks like Human Evil, MMLU, and HelloSwag by focusing specifically on agent-specific capabilities rather than general language model performance. While traditional benchmarks evaluate knowledge recall and reasoning in isolation, VAKRA tests integrated workflows requiring tool coordination, temporal reasoning, and adaptive strategy selection. The benchmark's emphasis on failure mode analysis provides insights unavailable in completion-focused evaluations, revealing how agents behave when encountering unexpected scenarios or tool limitations. Compared to agent-specific benchmarks like WebShop and ALF World, VAKRA offers broader coverage of reasoning types and more sophisticated tool integration scenarios. TopSpot multimodal evaluation approach surpasses single-domain benchmarks by testing agents across diverse task types within unified evaluation frameworks. The benchmark's failure recovery assessment provides competitive advantages for teams building production-ready agents, as most existing benchmarks ignore error handling capabilities entirely. VAKRA's limitations include computational intensity requirements and focus on complex scenarios that may not reflect typical agent deployment patterns. The benchmark's emphasis on multi-step reasoning may overweight capabilities less relevant for simple automation tasks. Organizations should supplement VAKRA insights with domain-specific evaluations and consider simpler benchmarks for initial agent development phases. VAKRA focuses on agent workflows via its general language model capabilities, and traditional benchmarks provides failure mode analysis unavailable in completion-focused evaluations like Human Evil offers broader reasoning coverage compared to domain-specific benchmarks like WebShop. Computational intensity requirements may limit accessibility for smaller development teams.
Good analysis. Let's continue. What's next? Future implications for AI agent development.
VAKRA's findings will likely influence the development of next-generation agent architectures, particularly in areas of reasoning verification and tool coordination. Expect major AI companies to incorporate VAKRA-style evaluation metrics into their agent development pipelines, leading to more robust failure handling and improved multi-step reasoning capabilities. The benchmark's emphasis on temporal reasoning will drive research into memory-augmented architectures and improve context management systems for long-running agent interactions. Integration ecosystem developments will focus on standardizing tool interfaces and improving agent-to-tool communication protocols based on VAKRA's tool use findings. Framework developers will likely implement VAKRA-compatible evaluation modes, making the benchmark more accessible for routine agent testing. Cloud platforms may offer VAKRA service evaluation capabilities, reducing computational barriers for smaller development teams. Long-term implications suggest a shift toward more sophisticated agent reliability standards in enterprise deployments. Organizations will increasingly demand VAKRA-style performance metrics before approving agent automation for critical workflows. The benchmark's influence will extend beyond technical development to regulatory frameworks and industry standards for autonomous AI system deployment. Major AI companies integrating VAKRA metrics into agent development pipelines, research focus shifting toward memory-augmented architectures for temporal reasoning, standardization efforts for tool interfaces based on VAKRA findings, enterprise adoption requiring VAKRA-style reliability metrics for critical workflows.
Great analysis. So what are the key takeaways from all of this?
AI agents achieve only 34% success rates on complex multi-step tasks, indicating significant reliability gaps for production deployment. VAKRA benchmark provides essential failure mode analysis missing from traditional language model evaluations. Organizations should implement VAKRA-style monitoring and production agent systems to identify performance degradation. Agent development teams must prioritize reasoning verification and robust error handling based on VAKRA findings.
And what market signals should our listeners watch for?
Agent reliability standards. VAKRA's revelation of 34% success rates on complex task signals an urgent need for improved reliability standards in agent deployments. This performance gap indicates that current agents are unsuitable for critical business processes without human oversight. Organizations investing in agent automation must reassess deployment strategies and implement comprehensive monitoring systems. The benchmark's findings will likely accelerate development of more robust agent architectures and drive increased investment in error handling capabilities. Evaluation framework evolution. The introduction of VAKRA represents a significant evolution in AI evaluation methodologies, moving beyond static benchmarks toward dynamic, multi-step assessments. This shift indicates growing industry recognition that traditional language model metrics inadequately predict agent performance in real-world scenarios. Expect increased adoption of workflow-based evaluation frameworks and greater emphasis on failure mode analysis in agent development processes. The benchmark's comprehensive approach will influence future evaluation standards across the AI industry. Enterprise adoption caution. VAKRA's findings suggest enterprises should approach agent automation with greater caution than current market enthusiasm indicates. The significant performance gaps revealed by the benchmark highlight risks in deploying agents for complex business processes without adequate safeguards. Organizations will likely delay large-scale agent implementations pending improvements in reliability metrics. This conservative approach may slow short-term agent market growth while driving long-term focus on production-ready capabilities and robust failure handling mechanisms.
What should developers and operators do with this information?
Integrate VAKRA evaluation metrics into agent testing pipelines within 30 days to establish baseline performance measurements. Implement production monitoring for multi-step reasoning failures and tool selection errors within 60 days of agent deployment. Require VAKRA-style performance reports from agent vendors before approving enterprise contracts exceeding $50K annually. Establish human oversight protocols for agent tasks with complexity levels matching VAKRA's challenging scenarios.
Thank you for listening to LeadAI.dev. Stay tuned for our next daily updates in this rapidly emerging market.